there's pluses. I'll find out. Okay, so B5 on it, yes. SI units, okay. So there's a bit of Neil spiel, as in, yes, we're not testing you on background here. It's nice to know some background. What is SI units? You know, what's it about? So just note again, there hasn't been much Neil presence, but Neil's in the top saying we're not testing you on this. So in the 1790s, a French commission was organised to determine a single scale for all measures. There was all sorts of measures, mostly obviously feet and inches and yards and all that. I never learned that. That was before even my time. But my parents did, and yeah, but different places were all different with their measuring systems. And so they came up with this and said, look, let's let the world convert to this. Obviously America didn't, but that was the plan. They came up with a meter. We'll see where they got it from soon, but you can see these things went up in the street everywhere to try and advertise, hey, this is a meter. All right. And they called it SI, like System International. So the whole world was meant to use it. And yeah, so that's why they called it SI. And yeah, it's a great system. It's also decimal. I mean, I don't know all the imperial stuff. I know there's 12 inches in a foot and I don't know, 3 feet in a yard, I think. And I don't know, something in something, stones and ounces. I don't know that stuff, but it was horrible. Like 16 ounces in a stone or something. I don't know. Not nice. You know, our system's pretty nice. You know, 10 of these, 100 of these, 1,000 of these. And that's what it's based on. The French said, okay, let's define the meter as it takes 10 million meters to get from the North Pole to the equator if passing through Paris. Okay, fine. And that's how we got a meter, because a meter is 1/10,000,000th of that distance. Okay, we know what a meter is. So from 1889 to 1960, they had a special exactly 1 meter bar in a museum. But even when I say exactly, I'm kidding myself. Nothing can be exactly 1 meter. I mean, to a million decimal places, it's just, anyway, there's a point at which it doesn't matter. But that was basically, they kept this at a certain temperature and they said, this is a meter. And people could go, scientists could go visit it and mark it off and take home their own meter. It's now defined in a very nerd way as the distance travelled by a ray of electromagnetic energy through a vacuum in approximately 1/300,000,000th of a second. Now, clearly Neil is still there. You might think, why is he saying all this? I just think it's good to know that a meter is now defined by that really weird definition, but that definition is exact. It's not like a length that I make out of wood or metal can never be exact. That's exact. That will never change, that definition. So that's why they have that nerd definition on it. Not that we care, we're just having fun. So the meter is a basis of measurement we know for length. Great. Area as well. When we do meter times meter, it becomes meter squared, which is a very algebra thing. X times x was x squared, m times m is m squared. You'll see that units in algebra are really the same thing, okay, when we do them. They're coming up. Volume, again, if I do a length times breadth times height to calculate the area of that cube-looking thing, I'll get m times m times n. Yeah, we know volumes in meters cubed. We also have volume as litre, okay? We'll talk about this later, but we know that we have 5 litres of something. So volume can be expressed in meters cubed, or centimeters cubed, variations on meters cubed, but also just litre. And let's just look at it right now. A lot of people then want to say litre cubed. No, a litre is already equivalent to a cube sort of a volume amount. Litre is volume. You don't write litre cubed. Litre is just for volume. You're going to measure nothing else in litres apart from volume. So just meters cubed, cool. Litres, cool. And again, we'll clarify what we care that you know and what you don't need to. I didn't put Neil there because I think this is important because you could get questions, you know, just a concept. 1,000 kilograms. I don't just mean car, I mean that model of car, that Mini Cooper is almost precisely 1,000 kilos. So it's just good to have some sort of concept of that's what 1,000 kilos looks like. A kilogram of sugar, fair enough. And a paperclip is almost exactly 1 gram as well. Within a few decimal places. So when we ask, you know, questions like how many grams in a kilogram, if we can picture just how big these things are, we've got less chance of writing silly answers like, I don't know, is it 10? No, 10 paper clips don't weigh the same as a bag of sugar. So we'll get the concept. It's actually 1,000 paper clips to a bag of sugar, and 1,000 bags of sugar will weigh like a car, a little car. Again, I've just got nerd content, talking about the grams. Basically, and this is still true, a gram is the weight of water equal to the 100th part of the meat blower. It's saying 1 centimeter cubed is a gram. Okay, is my pen working? No, not that. Don't do that. Yep. So basically, it's saying 1 centimeter cube, which is this little 1 centimeter by 1 centimeter by 1 centimeter. And let's use our algebra. What's 1 centimeter times 1 centimeter times 1 centimeter? 1 by 1 by 1 is 1. Yep, exactly. And cm times cm times cm is cm cubed. Okay, 1 centimeter cubed equals 1 gram if it's in water. Okay, so that's a nice little thing that if I fill this tiny little box the size of the tip of my finger with water, I'll get a gram of water. It's not the same for everything. Like if I fill it with steel, it'll weigh 2 and a bit grams. You know, everything's got different density. But water, a centimeter cubed of water is a gram. Okay, then they got all fancy. Okay, we've got this, they got a golf ball type prototype in the museum and that, but then they're going to define in terms of the Planck constant, give it one of these weird definitions, which is never changing, but it actually hasn't happened yet. So at the moment, it's still this, that's the gram in a museum. Fine. Now, second, time. Well, time, I think we're all over, we've dealt with seconds, minutes, hours. I think we'll be cool with this. Just the nerd content again, when Neil's sitting there, 1 second was defined as 1/86,400th of the mean solar day. And really, for all intents and purposes, that's what a second is. If there's 60 seconds in a minute, 60 minutes in an hour, and 24 hours in a day, there's that many in a day. But they want to get technical and say, oh, the day is not exactly 24 hours long. Well, we don't care. There's the fancy definition. Okay, no. But we know what a second is, minute, hour. That hasn't changed, okay? So the basic SI units, there's only 7 of them, okay? And the highlighted ones are the ones we care about. Meters, kilograms, and seconds, okay? We'll deal with them. There's amps and Kelvin for temperature. Degrees Celsius isn't actually the SI unit, though we use it, but it's really Kelvin, but they're very similar. Mole and candela, you might have heard of them, but we're not going to play with them in this course. I think I've got one question somewhere, I forget where I used candela, but that required no information about candela. It just, well, I'll explain that later. Why can you use candela when you don't need to know what a candela is? Well, no, I'll explain it now. We're going to ask questions like how many grams in a kilogram? Well, we're going to want to know very soon that if there's 1,000 grams in a kilogram. But what we're going to be saying is, who cares what the unit is, whether it's grams or not? How many meters in a kilometer? We're going to say 1,000. So I could just, how many liters in a kiloliter? We're going to say 1,000. So we could ask you a question, how many candelas in a kilocandela? There's 1,000. That required no understanding of what a candela is. We just have to know that kilo means 1,000. Okay? But basically, you'll see our question's going to base around these ones. Verse 3. And then looking at what else are we going to discuss? Well, these are the derived quantities. So I've already talked about meters squared and meters cubed. You probably understand, yeah, well, they were always going to be part of it. And it's velocity, meters per second. Okay? Sure, we talk mostly in kilometers per hour, and they're still our metric units. But SI, it's like a weird thing. Let's go back here. I didn't point out. Notice here's a weird thing. You'll think, wouldn't the SI unit for mass be grams? Because none of the others have prefixes on them. By prefix, I mean milli or micro or kilo or mega or giga or tera or peta. But the SI units has basically said they thought kilograms was more useful as the base unit. So that's more science than maths. But I'm saying that the base SI unit is actually meters, kilograms, and seconds that we care about. But again, I'm nerding it up and I need to shut up. Okay. We expect to know these derived quantities. Well, you'll see soon. We're going to do questions on meters squared, meters cubed, and meters per second. There's quite a few examples in this lecture, and that's exactly all the sort of things you'll need to know. You've probably seen our quiz questions and that. You don't get smacked in the face with something that was never in a lecture. Okay. Okay, we're fairly predictable in the sort of questions we're going to ask, and we don't bring in nasty surprises. Okay, unit prefixes. So I was already using the term. Okay, pre meaning prior, before, and fix meaning, I don't know. I shouldn't have said that. Kilo is combined with meter to form kilometer. We know that. Kilo is a prefix. It's put pre or prior to meter. Okay, so we know that that happens, and so meter might be our base SI unit. We can use kilometers. I've never heard anyone use megameters or terameters or anything, but it's apt, you know. But normally kilometers will do us. The Earth's not that big, but yeah. Now this, better than this statement, is just common sense. Look at this. Okay, if I'm doing some measurement and I say, oh yeah, this thing, we weighed it and it was 245 million milligrams. It's not wrong, it's just silly, okay? We get things to be more convenient. All this statement here is saying, when stating a result, we normally use prefixes to get it down to something a lot more manageable, to get the number to be somewhere between like 0.1 and 1,000. That's not a law, okay? That's just a usually, okay? That's like me in algebra saying, I usually write AB. If someone writes BA, it's the same thing. You don't have to. It's just, it's nice to just put them in alphabetical order. It's nice to write 2AB. I don't even like writing A2B. It's not wrong, but I hate it. So yeah, I don't want people telling me something weighs 245 million milligrams. So let's look at the process. How did we get there? Well, we need to know, and I'm going to say it, I've got a beautiful way to have on your resource sheet to remember these changes, okay? I'll get to in a sec. But at the moment, I'm going to use my knowledge, and some of you will know this, that 1,000 milligrams is actually equal to a gram, okay? We're going to learn that milli just means 1,000th. So there's 1,000 milligrams in a gram. So if I've got 245,000 of these 1,000 milligrams, well, that's 245,000 grams. And I know that 1,000 grams make a kilo, so I can then say 245 kilos. Again, if this is making sense, fantastic. If it's not, I've got a method that's, I'll use the word, that's foolproof. Even for doing these, it's a method that we're going to use for all conversions, all lecture, okay? I learned it in ChemEng, and it's, and I've seen the other sciences. I think Brian uses it, I think Zoe uses it. It's just a really good science and maths way to do conversions. Another example here is just, well, 1.23 million microliters. Well, that's just silly. Micro is another 1,000 down from milli. Micro means a millionth. So there's 1,000 microliters in a mil. So 1,000 microliters, it becomes mils. And then I've got 1 to 30 mils. And then you'll see taking 3 zeros off the end is exactly the same as dividing by 1,000, which is 3 moves smaller. So 1,230 mils is 1.23 litres. We're almost talking about a 1.25 litre Coke there. 1.25 litre Coke has 1,250 mils. Your nano is the next one down. So we got milli, and then micro, and then nano, okay, and then pico. So, yep, it's the next jump of 1,000 down, which is exactly what we're going to talk about soon. Jumps of 1,000, and you start to be able to visualize it, and you don't memorize this stuff really. It's sort of, I picture it. Yeah, got it coming. So the example here is, if someone says something was 8,600,000 millimeters away, first I'd smack them in the head, and then I'd say, oh, what's that? I'd say, well, 1,000 millimeters. Well, that's a meter, because there's 1,000 millimeters in a meter. So it's 8,600 meters. Then I'd say, oh, 1, 2, 3. That's 8.6 kilometers, okay? Much better way to say it. But anyway, we've got a method coming up, but I've got to do all this intro. So here we go. And there it is down there, nano and pico. So this isn't a memorized thing. This isn't the picture I'm talking about. This is going further than what we need in our course, okay? But this is just to get a look at, you know, what things are like, and especially the top end is a decameter is, yep, it's coming up because there's deci and deca. Yep. So a decameter is 10 centimeters, and there's a decimeter as well. Actually, a button. Yep. And that button. So again, don't look at that thinking, oh God, I've got to do all that. No, you don't. But just look at it. They're all leaks of 1,000. Tera. We're hearing about terabyte hard drives now. Not that long ago that giga was a new thing to hear. Okay. Now you don't get, you know, a megabyte. 1,000 megabytes is a gigabyte. 1,000 gigabytes is a terabyte, and so on. Of course, that's all getting bigger. kilobyte, and then note is here a base unit. Now, there's an issue with bytes, which I'm going to get to in a second. I do want to clear bytes away from it. It was very tempting to talk about bytes because we're so used to think. I don't think we've used tera and giga. Oh, gigaliters. You might see news reports about a gigaliter. Let's talk about liters for a second. Teraliters, gigaliters, megaliters, kiloliters, liters. You know, I just had a dash there. I mean, there's no prefix. Mils, microliters, nanoliters, and picoliters. So no matter what unit we're talking, we can stick, you know, the letter in front of it. Hectoliter, and again, we don't really go into that. So let's look at what ones we care about. The ones with the border around, let's get rid of the others there. They're the ones we're going to discuss. We're not going to go beyond mega in the bigs. We're not going to go under micro in the smalls. Okay? I mean, you can still, anyone that needs that, the rules we're going to learn here will work for giga, tera, everything. Okay? But we're just going to deal with these. And the only reason we're chucking in centi is because centimeter. Okay, it's used so often. I'm not going to bother with centiliters and stuff like that because it's just not normal. But we're getting a bit applied. Now, what's so special about this? Ignore the centi for the moment. There are 1,000, let's put milliliters there again. There are 1,000 microliters in a milliliter. There's 1,000 milliliters make a liter. 1,000 liters make a kiloliter, and 1,000 kiloliters make a megaliter. So that's why I just like lining that up. Clearly, centi isn't in that thing. I leave centi out of the side because I believe that we already know what a centimeter is. Okay, here's, clearly this is not to scale. Say that is 1,000 millimeters. In other words, that's 1 meter. Well, if that's 1,000 millimeters, I know this tiny little thing here is 1 millimeter. And I know 10 millimeters equals 1 centimeter. And I know 1,000 millimeters must be 100 centimeters. So if we've got anyone in the course that grew up in America or something, this bit's going to suck. But hopefully we've dealt with metric and we know that. But anyway, like I said, I've got stuff coming up that's going to help. But at the moment, this is all I want to focus on, leaps of 1,000. So let's look at the next page. That's what I'm talking about. That's my little helpful picture thing. If you can remember that, well, we've got a resource sheet, but that's going to get us out of trouble for all the next questions, and I'll show you how. So I know micro, milli, no prefix, kilo, mega. And yeah, that's carved in stone in my head. So how many mils in a litre? Well, I'll just write L's just for fun and look at where I'm talking about. Mils is here and litres is here. Well, it's only one leap. And I know that one leap is 1,000. Okay? So what I'm going to do is just count, well, how many leaps up the ladder are you making me go? From mils to litres is only one leap. And I know that every leap is 1,000. Or 10 to the 3. Please don't be put off by that notation because it gets really useful. When we start leaping by 3 leaps and I say, well, it's 1,000 times 1,000 times 1,000, it's much easier to write 10 to the 9 than one with 9 zeros. So just remember, 10 to the 3 just means 10 by 10 by 10, which is 1 by 1 by 1 with 3 zeros. So it's just beautiful that the 3 up here just tells you how many zeros you got after the 1. So 1,010 to the 3, 110 to the 2, 1,010 to the 6. Hopefully it makes sense. Yeah, there's 6 zeros, 10 to the 6. So it's a nice notation. So there's only one leap. So I'm going to say there are 1,000 mils in a litre, or 10 to the 3. Okay, well, let's try something else. How many milligrams in a gram? Well, I don't care whether it's a litre or a gram. It's the same question. Here again, I don't care if you're talking about candelas. Okay, that light stuff that we're not going to really deal with, but a gram has no prefix, so it sits there, and milligrams is there. It's 10 to the 3 again. All right, what else you got for us? How many micrometers in a meter? Can anyone see what that's going to be? It's going to be 10 to the something. Micro is down. I'll put my M's there again. Watch the trap. Hopefully we know that M is not meter. That M's micro. Oh, good start. Yeah. 6. Yep, 6 looks good. Now you've written the minus. I'll get back to that minus in a sec. But remember, that's milli. Okay, mega, kilo, nothing, milli, micro. But I can put my m's there. Micrometer, yep. Millimeter, yep. Meter, yep. Kilometer. Megameter might sound odd, but there's nothing wrong with it. And how many micrometers in a meter? So I'm jumping from there to there. And so it's, instead of just 1 leap, which is 10 to the 3, it's 2 leaps, which is 10 to the 6. I just think every leap gives me 3 zeros. So it's going to be 10 to the 6. Now, note, Aaron, I believe you're saying that, like, if I converted a meter to micrometers, a meter is 10 to the minus 6 micrometers. We're not going that direction. Okay, we're keeping it simple. No, it's all good. I'm just saying that we're keeping it simple here. I'm going to only ask you how many small things are a big thing. Okay, so we're always going to work up the ladder. So don't worry about negative powers here. Just say, I'm going to ask you how many smalls are in bigs. Big smalls. Wait, I don't even know who he is. How many micrometers in a kilometer? Well, micrometers here, kilometers here. That's it, 10 to the 9. Okay, hopefully you're seeing that what could be nasty is like, no, if I know this, if it's 3 leaps, that's 3 lots of 3s. It's 10 to the 9. What's another one? Okay, look, just saying here, and that's all good. I'm glad you said it, that if I'll just go back to good old, liters will do. This little thing I've got here, which is talking about mega, kilo, no prefix before it, so just liters, milli, and micro. I've just written this because there are 1,000 microliters in a mil. There are 1,000 mils in a litre. There's 1,000 litres in a kilolitre, and there's 1,000 litres in a megalitre, kilolitres in a megalitre. So these are all just layers of, I'm getting 1,000 times bigger as I go up the heap. But if someone asks me to jump more than 1,000, says, well, okay, I know you said there's 1,000 microliters in a milliliter, great, but how many microliters in a litre? Well, that's when I'll say, well, there's 1,000 of you in there, and 1,000 of you in there. I've leaped 2,000. That's 1,000 times 1,000, which is 1 with 6 zeros. 1,000 times 1,000 is 1,000,000, which is 10 to the 6. So all I'm saying is, no matter what question is asked of you, if you ask me how many of them in them, I'll say it's 10 to the 3. But if you ask me how many of them in them, I'll say it's 10 to the 6, because every step up the ladder is 10 to the 3. If you ask me how many of them in them, I'll say 10 to the 9. How many micro whatever grams in a kilogram? 10 to the 9, because it's 1, 2, 3 lots of 3. How many micros is the next one asking for it? How many microliters in a megaliter? Well, here's microliter, here's megaliter. 1, 2, 3, 4. It'll be 10 to the 12. So yeah, it's 1,000 of them and 1,000 of them and 1,000 them, 1,000 them. So there was 10 to the 3, another 10 to the 3, another 10 to the 3, another 10 to the 3. It's like I'm saying, well, what's 10 to the 3 by 10 to the 3 by 10 to the 3 by 10 to the 3? And we were told that all you got to do is plus these. 3 plus 3 is 6 plus 3 is 9. But the nicer way to think of it is just every leap up this ladder is 10 to the 3. 2 leaps is 10 to the 6, 3 leaps is 10 to the 9, and 4 leaps is 10 to the 12. So someone asked me, well, okay, well, how many millis are in a kilo? 10 to the 6. Each leap is 10 to the 3. So twice is 10 to the 6. So hopefully that's about okay. We've got a few, we're going to be using it a bit, but hopefully just think every step on this ladder, just this ladder, is a 10 to the 3. 2 steps is 10 to the 6, 3 is 10 to the 9, and 4 is 10 to the 12. And we'll be able to use those soon when we're converting. So that was 10 to the 12. That was 4 steps from there to there, so that was 10 to the 12. Okay, this, I just said, Neil's back, okay? I just wanted to explain why I'm going to treat bytes as the odd man out, and as much as I'd like to write gigabyte questions and stuff, I'm not going to, because there's a difference. This, actually, I'll admit, this probably sounds really bad. I aware at first. This actually happened to me. I did buy a new 8 gig hard drive, and it only had storage of 7.44 gigs, and I was peeved. Thinking, what the hell? Yeah, formatting takes up some room, but 0.56 gig I'm missing. 8 gig minus 7.44 gig. Where is my 0.56 gig? And I wanted back to Officeworks, and I wanted my gig, my 0.56 of a gig. But the truth is, you would think a kilobyte would be 1,000 bytes. Everything else, okay, grams, liters, everything else, a kilo that is 1,000 that. But computers have got to be different. Why? Because computers are all binary, okay? There is no group of 1,000 bytes in binary. Binary is all in, it's base 2. Let's think back to base 2. Oh, I probably shouldn't have done this. If we were looking at place values in base 2, we would have started with 1 by 2 is 2, by 2 is 4, by 2 is 8. Then we've got 16, then 32, then 64, then 128. Yeah, see, I shouldn't have done this. 256, 512. We're there. 1024. I just kept timesing by 2. And since computers work that way, they actually define 1 kilobyte as 1024 bytes. Oh, there it was, you idiot. So in computer terms, kilo represents 1024. So it's a bit, it's just, yeah, it's just the way computers work. I will not ask you these questions. We can lock in kilo into 1,000. I just don't want people thinking, oh, well, David said all of this thing, kilo always means 1,000. Well, not in the world of computers, okay? So how does that answer my question? Well, why? If kilo represents 1024, then a kilobyte will be 1024 bytes. Fair enough. A megabyte will be 1024 times 1024 bytes, which is this. So it's not a million, it's actually bigger. A gigabyte is times another 1024. So if that's a gigabyte, and I'm supposed to, and I'm thinking, well, doesn't gigabyte mean this? This divided by that will tell me how many gigabytes I've got, which is 7.45. Okay, total nerd info, but hopefully really underlining that just whenever computers are a little bit different, and that little difference of instead of using 1,000, they use 1024, makes this difference when we get up to gigabytes. Okay, no byte questions from me. So other important conversions we need to know, and once again, we'll just go straight onto a resource sheet. You may already know this, but a ton is 1,000 kilos. It's the odd one out. A ton doesn't measure anything else. I don't know why we needed a special term for a ton, but we do. A ton is 1,000 kilos. Okay, that little car weighs a ton. What other special ones? 1 mil equals 1 centimeter cubed. Totally. Now, notice if this is water, I could also write equals 1 gram. Okay, I'm not going to get you to do those conversions. We're not a science course, but we do need to know that 1 centimeter cubed. Again, here's my little. Well, I mean, but yeah, 1 centimeter by 1 centimeter by 1 centimeter. Would a gigaton be a teragram? But gigaton, it would be a tera kilogram. So it would be a petagram. Hang on, which one's first? I know you've made Haley leave. I'll get back to that. My head's hurting. Because which is next? Gigatera? No, peta. It would be a petagram, which doesn't sound good. Like a fat male stripper coming around to your house, a petagram. That's Family Guy. Aaron, you're putting me off. It's a good thing, but shut up, David. Okay, so 1 mil and 1 centimeter cubed are exactly the same thing. I don't care what the substance is. It's a measure of volume. 1 mil fits in that. I don't know if you've got any old measuring cups, or maybe it's just my old-fashioned house. I remember Mum giving us medicine in this sort of thing. And medicine, it might say, you know, like 5 mils here, or you might see 5 cc, or you might hear cc in terms of motorbike engines or something. That's just their way of saying cubic centimeters. Okay, 5 mils is equal to 5 cubic centimeters, or 5 centimeters cubed. Okay, so mils and centimeters cubed, just have it on your resource sheet, they're the same thing. And again, I like to picture it. The tip of my finger is a mil of human fluid, and it's also a centimeter cubed. What else do we need to know? Oh, that one. I think that's another one, good one to picture. 1,000 litres is equal to 1 metre cubed. I just like to picture that. That water tank, it's a small one, that looks about 1 by 1 by 1 metre, 1 metre by 1 metre by 1 metre. And yeah, if they all multiply, you get a metre cubed, and that will fill 1,000 litres. Okay. So I reckon I would have both of them on a resource sheet. Again, you'll see later, why would I want them on a resource sheet? Well, we haven't done many conversions yet. 4Z32, is that sort of what it's sounding like, Caitlin? I apologise if it does. But yeah, 1,000 litres fit in that thing. Okay. So there's my summary of them. Oh, that was your cousin. Okay. I thought that was like your analysis of the garbage I'm talking. So yeah, a tonne is 1,000 kilos. Yes, a mil is a centimetre cubed, and 1,000 litres is a metre cubed. We've also got the last of the funny units is hectare. But it's good to have because, well, it's used in real life. It's still immediately, I think, it's like with height. People often talk about basketballers. Oh, you know, Edric Lee yesterday, they were saying he's like nearly 7 foot. There are some things we just stick with old-fashioned measurements. Okay, I'm 185 centimeters, and people normally go, "Well, what's that?" Well, okay, 6'1". But yeah, people prefer to, yeah, they're just used to that. I think people still talk about how many acres they've got on their property. That's actually the old system of measurement, and I don't even know what an acre is. But a hectare is what we're meant to say. Okay, but we just sometimes live in the past. I do. You've seen that. What is a hectare? Glad you asked. It's 100 airs, where an air was 100 square meters. So basically, there's the paddock, okay? 100 meters times 100 meters, and that is a hectare. Why? And so 1 hectare equals, what's 100 by 100? Well, 1 by 1 is 1. 1, 2, 3, 4 zeros. That was what I had on the previous page. 1 hectare is equal to 10,000 meters squared. Nil's crossed out there because that info is useful. Not the top bit. But yeah, again, that's resource sheet stuff. But in my head, I don't memorize 10,000 meters squared. I just memorize that a hectare is 100 by 100 meter paddock. That makes sense to me because 10,000's odd. Normally things are in 1,000. You know, suddenly this one's 10,000. Why? Well, because they just defined a good sized paddock as 100 by 100 and they called it a hectare. Okay, I can handle that. That's a hectare. We're nearly done with here we go. We're done with building up all the info. I mean, that was a lot of info, you know, meters cubed, litres, hectares and all that. But then we need to use them. Where are we using them? And this is warm up, what I've written there, for this method that's going to work really well for you. Now, you might have seen it. They'll also use it in midwifery, science for nursing and midwifery next semester. They use it in drug calculations in the nursing courses. Like I said, I learned it in chemical engineering. It's everywhere and in the sciences. So my warm up to this, and please don't be off-put when I say the word fraction. The main thing people don't like about fractions is adding them, common denominators and that. I'm not talking about that. I'm talking about a concept of, well, let's look at this. That's a fraction. What's 5 divided by 5? How many 5s are in 5? Well, there's 1. Or I could think about it in terms, yep, 1, exactly. Or I could have thought of it, well, I can 1 5 there and 1 5 there. That's 1 on 1. Oh, that's 1. Okay, that's all I was after. What's x on x? If I've got an x on the top and an x on the bottom, is it related to the previous question? Well, it's 1, but it's you're close, but we don't have the x left anyway. I mean, maybe the x is a 5. If the x is a 5, I would write that. If I replace the x's with a 7, I would write that. If the x was 1028, I would have written that. What's the answer to any of these questions? So x on x is still just 1, okay? Because x is saying, well, let's look at it this way. How many x's are there in x? 1, not 1x. How many x's are in x? So basically the warm-up, the concept I'm trying to get is if the top equals the bottom, the numerator equals the denominator, you've got yourself the number 1, okay? That's the lesson from this slide so far. So whereas that might look odd, does top equal bottom? Does 60 minutes equal 1 hour? Yeah, that's 1. Okay, if top equals bottom, that question is saying how many hours are in 60 minutes? 1. How many 100 centimetre lengths are in 1 metre? Seen a trend yet? But as long as top equals bottom, it's equal to 1. Another concept, 5/7 times 7/8, and this is as fraction as we get. And it was just a really nice thing that, remember, if we looked at that, sure, I could times across the top and the bottom, but there was a quicker way, which was saying, oh, you got a 7 on the top and the bottom. And we would cancel a 7 and we'll cancel a 7. Now, normally, yes, I would write that 1 there, but here I'm going to even shortcut. I'm just going to say, look, there's a 7 there and a 7 there. They've gone. The answer's 5/8. Again, I'm just hoping that you're nodding, going, yeah, okay, I can handle that. If I've got the same thing on the top and the bottom, I can cancel them. It's the same thing as what we did here. I cancel the 5 and cancel the, yeah, okay. What else do you got for me? Another one there. Oh, well, that's the same. If I've got a 3 on the top and a 3 on the bottom, they can disappear. If I've got a 4 on the top and a 4 on the bottom, they can cancel each other out. The answer there is 2/7. So if you're still nodding, yeah, we did this before, then it's looking good. What else you got for us? Okay, you've chucked algebra in. I don't care. Anything there we can get rid of. Is there anything there that's on the top that's also on the bottom that I can cancel out? That being a hint, really. If there's an x on the top and an x on the bottom, the x is just some number, I don't know, but it can go. If 7 can cancel, so can the x's. There's nothing else can go, so my answer here would have been 6 on 55. But can you cancel an x on the top and x on the bottom? Absolutely you can. This is where we're heading to. All of that prep was to do things like this. This little question here is an odd-looking way to say, the question here would have been, can you please convert 3 hours to minutes for me? And I've said, well, here's 3 hours. I've written it as a fraction because this is, you can see there's a fraction thing going on. I just put over 1. I can put anything on 1 that I want, okay? Now, what I've done is times it by 60 minutes on 1 hour. Would you agree that 60 minutes on 1 hour is equal to the number 1? Yeah, we agreed with that. So I'm allowed to times 3 hours by the number 1. I can times anything by the number 1. But look, if I've got hour on the top and an hour on the bottom, like an x on the top and an x on the bottom, the hours are cancelled. So the reason I did that with the x is to say units can cancel. And let's look at what I've got left. Fractions told me all I've got to do is times the top. I've got 3 times a 60 and the word min. 3 times 60 is 180 and the word min is there. On the bottom it says 1 by 1 and there's no word. And I don't have to write on 1. That just converted 3 hours to minutes for me. Thinking I already knew 3 hours was 60 minutes. That just made life harder. No, it's maybe. But if you can get hold of this method, you can use it for anything. Complex ones, easy ones. Every single conversion can use this method. And it's gold, it's a winner. I'll admit now that if people choose not to use this method throughout this course, that's okay. But I'm pleading with you to give it a go. After you get through the initial awkwardness of it, to get the hang of it, it's like, actually, this is really quite easy. I'm here to try and convince you of that. Look at this one. Someone asked me about 500 centimeters, and I can analyze on this. The question was, give me 500 centimeters, but convert it to meters, please. All right, here's my 500 centimeters that you gave me. I stuck it over 1 again because I want to work with fractions. Now, I wanted to get rid of centimeters. So if I want to cross out cm, I'd better put a cm on the bottom. All right. And I do want the units m because someone asked me to convert centimeters to meters. So I want an m on the top and a cm on the bottom. That's all acceptable as long as whatever numbers I put here make top equal bottom. I've always got to, I can't just times it by anything I want. But 1 meter is equal to 100 centimeters. We did that. So what I've written here is totally right. I'm getting 500 centimeters and timesing it by the number 1. Well, centimeters will go. Look, 0, 0, 0, 0. We've done those with fractions. I can lose 2 zeros on the top, zeros on the bottom. It's still the same stuff. All right, I've cancelled everything I can. The only thing it says on the top is 5 times 1, which is 5, and m. On the bottom it says 1 by 1 with no, it's 5 meters. Okay, so this system gets rid of the units we don't want, brings in the units we do want, and it does all our work for it. I've got lots of examples of this. I hope I'm going to convince you. So this is called the conversion factor method, and all of these things, hopefully you agree, they're all good. They all equal 1. 1,000 meters equals 1 kilometer. That's cool. That equals 1. If I turn upside down, still equal 1. 60 minutes is 1 hour, 1 hour. Yeah. So I can come up with all sorts of whatever. 60 seconds on top of 1 minute. That's a conversion factor. That's equal to 1. Okay. And be careful. Don't misread them. One minute on 60 seconds. Sort of at a glance looks, yeah, that looks cool. Oh shit, it is cool. 1 minute on 60 hours. Again, at a glance, you might think, yeah, but no, stop. 1 minute does not equal 60 hours. If you put 1 hour on the bottom and 60 minutes, okay, I'll accept that. 60 minutes over 1 hour. Yeah. So it's, okay. It's not too bad. We can work out if these things are equal. 100 centimeters equal to a meter? Sure does. All right. Let's get in then. I've written my cheat sheet to the side. I love having that there. Again, the only thing that doesn't help with the centimeters, but I know about centimeters. Convert that to meters. Now, if you already know the answer to this, again, you don't have to use this conversion factor method. Some of you might look at that and say, there's 1,000 meters in a kilometer, so I'm going to move that 3 places, and it's going to be 32 meters. If you've got methods, whatever, but I'm going to do it this way. You're asking me about 0.032 kilometers, and I put everything over 1. Now, here's my process. I don't want kilometers. So if I've got kilometers on the top, I want to get rid of them. So kilometers on the top will be gotten rid of if I put kilometers on the bottom. What is it I do want? Meters. I'm nearly done. All I've got to do is write the appropriate numbers, because it's not 1 meter equals 1 kilometer. That would be wrong. I've got to think, 1,000 meters equals 1 kilometer. That's totally acceptable. So the units, the question told me where to put the units. Get rid of that and bring that in. And the numbers, well, I can look at this. Here's meters, here's kilometers. That told me there's 1,000 meters in a kilometer. Okay, absolutely. So let's do our cancelling then. Kilometers is gone, top and bottom. There's nothing else to cancel. But it told me the bottom is now 1 by 1. I don't even care about 1 by 1, but it told me 0.032 times 1,000. Well, I know 1,000 is 3 moves bigger. And there's an M left. You can put the on 1 if you want. So again, there are some people that are going to look at this and say, look, I already knew it was 32 meters. Fantastic, you're done. But look at what this method did for us. If you were thinking, I know it's to do with 1,000, but should I times or should I divide? Which way should I move the decimal point? This method told us the 1,000 is on the top, not on the bottom. If it was 0.032 on 1,000, well, then I would have moved it smaller. But it was times 1,000, not divide by 1,000. So I'm just going to keep churning through after example and show you it gets really repetitive. Again, if you get on top of this, the rest of the lecture is repetition. Another one. Okay, now you've got 580 micrograms to grams. All right, I just write what you gave me. Nah. Why now wrong pen. No, it's all right. One pen works, one pen doesn't. If I press that, thank you. Okay, 580 micrograms, which I know is down there. I'm going to grams. So instantly I can see my conversion factor is, well, whether you want to call it 1,000,000 or 10 to the 6. I know that every leap was 10 to the 3. This is 10 to the 6. Okay, I'm going to need that because, look, I'm going to put that over 1. I don't want micrograms, so I'm going to put that on the bottom. And I do want grams. I'm doing exactly the same thing I've done every time. Now, this conversion tells me that 1 gram is equal to a stack load of micrograms. Now, I'm actually thinking at the moment, what would I rather write? Would I rather write the million? Or would I rather write the 10 to the 6? Whatever, I'm going to write the 10 to the 6. Okay, well, let's look at what's happened. The microgram units is cancelled. So you can see my answer is going to have grams. Let's just write it again. The top says 580 times 1, and it's got a G. So it's 580G. The bottom says 1 by 10 to the 6 and it's got no letters. There's my answer. But surely we can make that look better than that. And just think, 580, it's grams, definitely. If it said times 10 to the 6 for 580, I would move the decimal place 6 times bigger. But it says 580 divided by 10 to the 6. That means I've got to move 6 places smaller. That's all. 580 is being divided by 10 6 times. That's just 6 moves smaller. Here, let's get the 580, and I'll just stick some here. I don't know how many we need. The decimal point was there. 1, 2, 3, 4, 5. There it is. My answer is 0.000580. Doesn't matter whether I write that final 0 or not, but yeah, it told me exactly what to do. And let's look at the whole thing. It was a 50-50 question. As soon as I saw it was 10 to the 6, I was moving a decimal place 6 spaces. Was it going to be bigger or smaller? Well, the question told me smaller. Okay? All of these questions are a 50-50. Which way do you want me to go? And because the 10 to the 6 was on the bottom, let's divide that smaller. If it was on the top, it would have been bigger. Again, I'm going to do another example. Let's see it all happen. Okay, this one's already in scientific notation. Great. 4.2 by 10 to the 12 milliliters. I write all these things over 1. I don't want milliliters. I'm going to put milliliters on the bottom. I do want megaliters. Okay. So all I've got to do is, it's going to be 50-50. I'm going to have a big number. It's either going to be on the top or the bottom. Well, let's look. Megaliters is here and milliliters is here. Yoink, yoink. That's 3 leaps. That's saying there's 10 to the 9. 1 megaliter is 10 to the 9 of these little things. 1 megaliter is 10 to the 9 mils. That just answered my question. Was the big number going to be on the top or the bottom? It's going to be on the bottom. That number's going to get smaller. Look, mils is gone. Got to be careful when dealing with milliliters and megaliters, because especially my writing, yeah, little m and big M tend to look a little bit alike. Okay, now what I really end up with is 4.2 by 10 to the 12 megaliters over 10 to the 9. Think back to last week. What happens there? A 10 to the 12 divided by a 10 to the 9. We did that, and it wasn't that bad. And whatever way you want to think about it, you either think, maybe you're thinking 10 to the 12 divided by 10 to the 9. Wow. That was just subtracting powers, wasn't it? Or it's like there's 12 tens on the top and 9 tens on the bottom. So if you cancel 9, there's still 3 tens on the top. But yeah, 10 to the 12 divided by 10 to the 9 was just 10 to the 3. Divided by meant subtract the indices. So 12 minus 9 is 3. 4.2 by 10 to the 3 megaliters. So yeah, 50-50, and we had to go smaller. 9 moves, 10 to the 12 smaller by 9 moves, took us down to 10 to the 3. Okay, now into the lecture ones. Here, you might know this answer already just from looking at it, because mega literally means a million. The answer here, 47 megaliters, is literally 47 million liters. But I'm going to use the method again. Here's my megaliters. I don't want megaliters, so the top cancels with the bottom. I do want liters. And how do liters and megaliters relate? 10 to the 6. It's 2 leaps of 3. So that means 1 megaliter is 10 to the 6 liters. Absolutely. So the megaliters is gone. I'm literally looking at 47 by 10 to the 6 liters. Now remember, this question doesn't say in scientific notation. Remember, there's nothing wrong with that. 47 by 10 to the 6. There's nothing wrong with that. But let's just test ourselves a minute. If the question asks for scientific notation, remember that 47, we don't do that. If it was, I'd make that smaller. I'd make that 4.7 if it asked for scientific notation. 47, 1 step smaller, becomes 4.7. So I've got to make this bigger. So it'll be times 10 to the 7 liters. They're both 100% correct answers. I'm just practicing last week a little bit, saying, if it said, give me the answer in scientific notation, fantastic. Well, the other thing is, I didn't have to do this at all. I could have said, what's 47 by 10 to the 6th? Well, it's 47, 1, 2, 3, 4, 5, 6. They're all good answers. But if mega means million, the answer is always going to be 47 million litres. Okay, let's keep caning this method. All right, I've got a 3 by 10 to the 5 micrometers, but I want millimeters. So if I want to get rid of micrometers off the top, I'll put micrometers on the bottom. I don't know, I didn't really talk about that symbol before, micro. It's like a running writing U, okay? It's a mu Greek letter thing, but it's like a running writing U, okay? Micro. In my head it means a millionth, but yeah, micro is that running writing U. Okay, so, but I do want millimeters. So I want micrometers gone and I do want millimeters. Well, where do they sit? Micrometers is down here and millimeters is there. There's 1,000 micros in a milli. 1,000 micros equals 1 milli. Hopefully you see why I like that thing at the side. And again, whether you want to write 1,000 or 10 to the 3, it's your call. I'd probably write 10 to the 3 here because we've got another nice thing coming up. I can see what's going to happen. Hopefully you can too. A 10 to the 5 and a 10 to the 3 will be a 10 to the 2. Okay? If I times 10 to the 5 by 10 to the 3, it'll be 10 to the 8. But if I divide them, it'll be 10 to the 2. When you times, you add the powers. When you divide, you subtract the powers. So micrometers, you're gone. The answer's in millimeters. It's the only units left. And like I said, 10 to the 5 over 10 to the 3 is 10 to the 2. Oh, I hate you. And that'll do. What's that as a normal number? 3 by 10 to the 2. Maybe you don't have to write in scientific notation, it is. But 3 by 10 to the 2 is just 3 times 10 by 10. Or think of it as 3 times 100. Either way, they're all good answers. No one told us how to write it. Now, I'm hoping that that question just looks a lot nicer. Because I bet, oh, I may be wrong, it looked a bit horrible, and it still may. But look at what we did. I hope that made sense. I hope you know I put the micro on the bottom because that was on the top. I put million on the top because that's what I was asking for. The numbers I got from here, and last week told me 10 to the 5 on 10 to the 3 is 10 to the 2. So I'm hoping I'm making sense of it. Keep pushing through. Oh, okay. There's more coming. We're not done. But of course we've got to add a twist. It's not a big twist, but it's essential. Like I said, everything we do today from this point on, it's the same stuff, okay? Even this is going to be the same. Sorry, just water. We know that meters times the centimeters gives, wow, start again. We know that meters times 100 gives centimeters. For example, if someone asked me what's 6 meters in centimeters, I'd answer them 600. It's doing it more and more. Stop it. So what do? I times by 100. Okay, yep, that makes sense. All right. What's your question? What about meters squared? Okay, well, meter squared times what will give me centimeters squared? Your gut instinct is like, well, just times 100. Meters squared, whatever it is, it's not, okay? Meters and meters squared are two different things. Meters are lengths, meter squared is an area. And here's my picture to make sense of, well, what do you want me to do? That box there, that square, is 1 meter times 1 meter. The area of that is 1 meter squared, because 1 times 1 is 1 and m times m is m squared. Okay, if that's 1 meter squared, then this is also 1 meter squared. I've just, instead of calling it 1 centimeter breadth, I've called it 100 centimeters. Instead of 1 meter width, I've called it 100 centimeters width. They're exactly the same thing. So what's the area? What's 100 centimeters times 100 centimeters? 10,000 centimeters squared. There's the difference. It wasn't 1 times 100 becomes 10,000 is 1 times 100 times 100 again. Why? Because that's exactly what we did. I turned the 1 meter into 100 centimeters. How did I do that? I times by 100. I turned this 1 meter into 100 centimeters. How did I do that? I times by 100 again. So hopefully it makes total sense that if I'm talking about meters squared, you don't just have to convert one thing from meters to centimeters. You got to convert 2 things from meters to centimeters. Do it twice. Whatever I would have done here from meters to centimeters, just times by 100 once. To do it for squared, do it twice. That's the way we're writing it. Times by 100 squared, which is the same as saying times by 100 times by 100 again. That's it. That's the trick with meters squared. If you can do it without the squared, do it twice if it is squared. The 2's telling you, do it twice. Let's check on this. So for square meters, square the usual conversion. Do what you do without it. And then, so like this, 2.16 meters squared to centimeters squared. If someone asks me a different question, what's 2.16 meters in centimeters? I would say 2.16. I know there's 100 centimeters in it, and we can still use the conversion factor here. Multiply by 10 to the 4th, it's the same thing, yeah. So if someone said, without the square, 2.16 meters, I would say it's 216 centimeters. I would times by 100. But I've got to do it twice. 2.16 meters squared. Since it's squared, I won't just times by 100, I'll times by 100 squared. Which, as Aaron said, they're exactly the same as calling it 10 to the 4. Okay? Now, there's so many ways you could do this. You could think times by 100 would do this. So it'll get me to 216. Then do it again. Will become 216.00. That's okay. You did 2 moves twice. Aaron's looking at it as, what's 4 moves all up, isn't it? Because 100 squared is 100 by 100. He's looked at that and said, look, all I need to do is 4 moves. 1, 2, 3, 4. Yeah, 1, 2, 3, 4. Who cares what way you do it? 2 steps of 2, 1 step of 4, do as you feel. But just do what you would have done without the squared, but do it twice. Yeah, I did that by myself. I don't need your help. Cube, same thing, but do it 3 times, okay? You can see that if, well, there's 1 meter cube, 1 by 1 by 1 meter. That's 1 meter cube. If I did that, can you see? I've got to convert 1 meter to this, to this, to this. So all it means is, now it's 1,000,000 centimeters cube. If you want to convert meters cube to centimeters cube, times by 100 3 times. Okay, so if we can lock in squared and cubed are exactly the same as without them, but do it 2 or 3 times, we can answer all these questions. Okay, convert 0.06 meters cubed to centimeters cubed. Well, I've probably got it nice here. If I was doing it without the cubed, 0.06, I know that meters times 100 gives centimeters. Okay, fair enough. Excuse me. Okay, so meters. So you're saying 10 to the 6? It's totally right. It will be 6 moves, because if we just would have times by 100, but now we're talking about cubed, I'm going to times by 100 cubed, which again, you might think, well, times by 100 is 2 moves bigger. I'll do that 3 times. Well, what's 2 moves doing it 3 times? It's 6 moves. Whichever way you think about it. And again, I would have been down here and saying, you want me to make you bigger 6 times? Well, I better chuck some zeros on. Let's see how many we need. 6 moves, it said. Or 3 moves of 2. There's my first 2 moves. There's my second 2 moves. There's my third 2 moves. In other words, there's my 6. What's my answer? 60,000. Yep. Actually, no tricks, no traps. And I've got another method for this, which you may prefer. So algebra gives okay, no worries, Aaron. Okay, so great, we've got a method. But let's also look at this. Up here, I'll do 2.3 meters squared to centimeters squared. First, I'll do it the way I've just been doing it. 2.3, if it was just meters, and I wanted to go to centimeters, I would just times by 100. But if it's 2.3 meters squared, well, I better times by 100 twice. So the first times 100 gives me 230. The second times 100 gives me 2 more zeros. So it's pretty quick. But the conversion factor method, I did say before that method we're learning could be used in every single question. Prove it. Okay? Here's 2.3 meters squared. And every time I use a conversion factor, if it wasn't a fraction, I just put it over 1. I don't want meters. I don't want this m anymore, so I'm going to put an m on the bottom. And I do want cm. How do centimeters and meters relate? Well, I know 1 meter equals 100 centimeters. But what's wrong? Meters squared doesn't cancel with meters. That's not true. A single m doesn't cancel an m by m. All right, I better write it twice. Would you agree that at the bottom now, that's an m times m. That's an m squared. Yes, it cancels now. So what's the trick? If you're doing centimeters squared, you've got to write your conversion factor twice. And if the question was cubed, I would have written it 3 times. So you can choose whether you want to go this way or this way, but notice that this conversion factor method, all you've got to know is for squared, I've got to write it twice. And it's logical because if I want to get rid of m squared, m times m is m squared. Let's look what happened. It's telling me get 2.3, times it by 100, then times it by 100 again. I knew that. Yeah, birdie. 230, 0, that's me times it by 100 twice. And what units are left? Centimeters times centimeters. That's exactly what we wanted. So the conversion factor method still works. Just do it twice for squared and 3 times for cubed. So I'll probably stick with that method because it's nice to have one method to do all these questions. It's not dinner time. We'll get there. Okay, up the top I'll do the straight method, which was 370,000 millimeters. So I'm doing it without the cube. I'm just reminding myself, what would I do to get that to centimeters? And I just think in my head of an example. It's like 20 millimeters is 2 centimeters. 10 millimeters is 1 centimeter. 10 millimeters is 1 centimeter. So if I divide by 10, it'll only be 37000 centimeters. Personally, I don't like that top method at the moment. I mean, I'm still writing it there. Conversion factor method tells me whether to times or divide. It's much easier if you're not sure of what you're doing. But I'm confident here that, yes, 20 millimeters is equal to 2 centimeters. And I'm showing this, that, yeah, it's a divide by 10. So to do it, I must have to do it 3 times. Divide by 10 cubed will be 3 times. Will just be 370 centimeters cubed. Let's use the conversion factor method. Might be nicer. 370,000 millimeters cubed. I don't want millimeters, so I'll put it on the bottom. And I'm going to do it 3 times because it's cubed. I do want centimeters. And all I've got to know is how do centimeters and millimeters relate. I know 1 centimeter is 10 millimeters. And look, it just told me what to do. It said the 10's on the bottom. Cancel them. 0, 0, 0, 0, 0, 0. Millimeters cubed cancels millimeters, millimeters, millimeters. I mean, come on, how pretty is that? Look at the answer. 370 times 1 times 1 times 1 is 370. The units are cm times cm times cm, which is cm cubed. And there's nothing but 1s on the bottom. Nice. Any hushes, small rounds of applause for the conversion factor method going? Well, it's not too bad. Oh, 6. There's only 5 people now. Oh. Okay, I'm going with the conversion factor method. 55 centimeters to start with, 55 centimeters squared. I'm putting you on 1. I don't want cm, so you're going on the bottom twice because you're squared. I do want mm. Then I know centimeters and millimeters. I know it's 1 of one is 10 of the other, and hopefully know that it's 1 centimeter is 10 millimeters, 1 centimeter is 10 millimeters. Oh, that wasn't too bad, was it? it's telling me the centimetres squared is cancelled by these centimetres. It's saying 55 by 10 by 10. Look at that. Converted. Very pretty. Give us more. See, chucked a lot of examples in. A cube's, all right, 12,000 centimetres cubed. Make you look like a fraction. I don't want centimetres. You go on the bottom 3 times because you're cubed. I do want meters. And if you grew up around these parts or many parts of the world, you know 1 meter is 100 centimeters. 1 meter is equal to 100 centimeters. So I see what you're saying. I've got a lot of division going on. Let's at least get rid of 3 zeros. 3 zeros off the top and 3 zeros off the bottom. I can't do any more. The centimeters cubed is gone with the centimeters cubed. So what have I got left? I've got a 12 times 1 times 1 times 1 mm on the top. On the bottom, I've got 10 times 100 and no letters. There we go. There's the answer. It's 12 thousandths meters cubed. But what's 12 divided by 1,000? That's just the number 12 with 3 moves backwards. 1, 2, 3. I mean, it could be 12 on 1,000. It could be 6 on 500. It could be 3 on 250. I'm just saying, we normally use the decimal answer. And 12 divided by 1,000 is just 12 with 3 moves back. 0.012 meters cubed. Beautiful. It's doing all sorts of stuff for us. Okay, we're probably getting near the end of these examples. Good. Now, there's only 2 bits left, and they're the same. Okay, like I promised. We're using the same conversion factor method. Now, you'll notice this spiel about rates. Just think speed. Speed's a rate. Speed is the rate of change of distance when compared to time. As soon as I say kilometers per hour, like in per, basically means fraction sign. If I say 60 kilometers per hour, I'm basically saying 60 kilometers per 1 hour. Every 1 hour, I travel 60 kilometers. That's a rate. Okay. So the difference here is if we're going to be converting rates, instead of me having to just get whatever the question is and put it over 1 to make it look like a fraction, it already is a fraction. What if someone says, look, there's on this conveyor belt, 25 kilograms goes past here every 2 minutes. That's a rate, okay? 25 kilograms of product goes past every 2 minutes, there's a rate. What if I've got a dripping tap and they say, oh, I'm losing 6 litres for every hour? Well, that's 6 litres per 1 hour. So rates start out as fractions. Great. Yoink. Okay, convert 72 kilometers per hour to meters per second. We're going to do exactly the same as the others. 72 kilometers per 1 hour. All right, now let's look at what I want. I don't want kilometers. I want to convert it to meters. And I don't want hours. I want seconds. Let's just, it doesn't matter which one we pick on first. I'll pick on kilometers first. I don't want kilometers. So km on the top, km on the bottom. I do want kilometers to be meters. That'll do it. How many kilometers equals how many meters? Well, I know 1 kilometer is 1,000 meters. Okay, my little mega kilo base milli micro tells me that. How many meters in a kilometer? It's just 1 leap, 10 to the 3, 1,000. All right, kilometers is gone. But we haven't done anything with the hours yet. Okay, well, 2 methods here. Firstly, I want to go to the side and try and work out something which then I'll forever have on my resource sheet. How do hours and seconds relate? How many hours are there in a second? I mean, how many seconds are there in an hour? Well, I know that there's 60 seconds in 1 minute. And I know there's 60 minutes in 1 hour. So I know that if here's an hour an hour is split up, worst picture ever, into 60 minutes. And every minute is split up into 60 seconds. It's 60 times 60. There are 60 lots of 60 seconds in an hour. What's 60 by 60? What was our method for that? We said 60 times 60, do the numbers, and ignore the zeros, do the numbers, chuck the zeros back on again. 6 by 6 is 36. 2 zeros. That gets used a bit here. 1 hour is 3,600 seconds, which makes sense. It's 60 by 60. All right. Now, be careful here. I'm going to go to blue for a sec. I've got hours on the bottom. So where do I want hours? Everything I've gotten rid of to date, I've said, you're on the top, so I'm going to put stuff on the bottom to get rid of you. But this is the opposite. I've got hours on the bottom, so I want hours on the top to get rid of it. I do want hours convert to S. I want S on the bottom. So the only difference is it's upside down to what we're doing, but just follow the same rule. If you want to get rid of something off the bottom, put it on the top. I can say 1 hour is equal to 3,600 seconds. So now hour is cancelled, and we've done it. We've got to do the simplify the number, but look at the units that are left. I've got an M there and an S there. So my answer is in meters per second. Can I cancel anything? Well, there's a 0 and a 0 and a 0 and a 0. I can cancel 2 zeros. 72 and 36. You could leave this and do a division later, but 2 times 36 makes 72. So there's 1 36 there and 2 36s there. If you can read your own writing, I then say, what have I got left on the top? 2 times 10, M. That's 20 M on the top. What's on the bottom? 1 times 1 times 1 S. So the answer is 20 meters on 1 second, which is 20 meters per second. So this is the worst of all conversions. And I don't think it's the most horrible thing we'll ever have seen. Again, we've got a method for doing it, and the method works every time. I want to chuck something here for a sec, just to make a point that I could have done it this way. I just like the way I did it. 72 kilometers on 1 hour. Again, kilometers is on top, so I'll put it on bottom, and I do want meters because kilometers is going to meters. Instead of going straight from hours to seconds, I could have used minutes. Like, let's look at this. If 1 hour is on the bottom, I could have put an hour on the top and minutes on the bottom. 1 hour is 60 minutes. But that would only have gotten rid of hours, and I'll still have minutes. So then I'd want minutes on the bottom would cancel minutes on the top. 60 minutes is equal to 1 hour. Look what's happened now. That's not right. Yeah, 1 hour is 60 minutes. Oh, I went back to hours. Idiot. I'm doing it again. 1 minute is 60 seconds. If I want to get rid of minute and minute, then I've got to do that. You see how it's still going to work out. I've still got it on 60 and an on 60. I just prefer the way we just did it. I'd rather do it in one step. Instead of doing all of this, I'd rather just do 1 hour over 3,600 seconds. Same thing, but I don't know. I want to write as little as possible. So just note they're the same thing. That'll get hours to become seconds. Let's do another. Convert. Okay, the other direction. It's going to be the same thing. There's going to be a bit upside down. Could have said the answer is going to be 36 kilometers per hour because 20 meters per second we found out was 72 k's per hour. So 10 must be half of that. Let's do it. 10 meters per 1 second. That is the rate I'm traveling at. Okay. I don't want meters. So M's going on the bottom. I do want kilometers. What units do I put there? I know 1 kilometer is 1,000 meters. Great. Okay. So that's going to sort the meters. Seconds to hours. Okay. Seconds is on the bottom, so I better put seconds on the top. And I do want hours. And again, I remember that 1 hour is equal to 3,600 seconds. Cool. Okay. So seconds is gone. Seconds is gone. Look at what I've got left. Kilometers over hours. Perfect. I've done everything I need to do. What can I cancel? Well, I've got a 0 there and a 0 there, and a 0 there and a 0 there, and a 0 there and a 0 there. That's pretty. 3 zeros on top and 3 zeros on the bottom. The top now says 1 by 1 by 36 km. The bottom says 1 by 1 by 1h, which is 36 kilometers per hour. Tell me that's horrible. You can't, can you? Okay, so we can convert kilometers per hour, meters per second. We're basically using, well, what we've learnt with numbers, what we've learnt with fractions in order to do our unit conversions. Okay, where's my magic number? 45 slides. Okay. All right, it's another rate one. It's got a little twist in, but let's see how good our resource sheet is. I mean, theoretically, I know you haven't written it. 5 centimeters cubed per single minute. It doesn't matter whether I write the number 1 there. I just like to, I don't know. That just reminds me. So this, it might seem weird, but 5 centimeters cubed per minute. This could be water dripping out of a tap. I'm losing 5 centimeters cubed of water every minute. Yeah, okay, it's still a rate. All right. Now let's look at what I do and don't want. The minutes linked with the hours. That's easy enough. This one looks a bit trickier. I have nothing on my resource sheet which tells me how centimeters cubed relates to litres. So I've got to have a bit of a think about how do I relate these. Sorry, just getting the jacket on. Looking at my resource sheet, the two things, remember that picture of that little beaker? That little beaker said 1 centimetre cubed equals 1 mil. And there was the picture of a 1 metre cube water tank which fit 1,000 litres. They're the two that will always get you out of trouble. Look at the top one. I want to go for that. 1 centimetre cubed and 1 mil, they're exactly the same thing. So I can either just rub out centimetres cubed. I can rub out centimetres cubed and write mils. If they're exactly the same thing, 5 centimetres cubed is 5 mils. Okay? Or I could be nerdy about it and say, I don't want centimetres cubed, so I'm going to put centimetres cubed on the bottom, and I do want mils, I'll put you on the top. What should I times by? 1 mil is 1 centimetre cubed. Same end result, isn't it? To me, I'd rather just scribble on the question. I'd get rid of centimetres cubed and call it mils, because they're exactly the same thing. I can picture it. That's a mil, and that is a centimetre cube. Okay, what about minutes to hours? Easy. There's minutes on the bottom, so I'm going to put minutes on the top. How do minutes relate to hours? Oh, me. 1 hour is 60 minutes. There's all my working done. Any cancelling? No, they're all ones on the bottom. That's not going to happen. What about units? Min gone, min gone. So units I've got left as mils over hours. Oh, I haven't finished. David, too cocky. I didn't ask about mils per hour. I asked about litres per hour. So I don't want those mils. I want litres. Again, mils was on the top, so I put mils on the bottom. What are the numbers? 1 litre is 1,000 mils. Now I've finished. Bad kid. All right. Oh, I'm going to lose a 0 from the top and a 0 from the bottom. What have I got left? 5 times 1 times 6 times 1. That's 30. What letters have I got? L. The bottom, 1 by 1 by 1 by 100. Letters I've got, H. 30 on 100 litres per hour. Okay, let's lose a 0. 3/10 litres per hour. 3/10, that's a 3, that's 0.3. 3 divided by 10, whatever. These are all good answers. Yeah, we did it. If I was losing 5 centimetres cubed per minute from the tap, I'll lose 0.3 of a litre per hour. Excellent. That's probably the last of them. Is it conversion rate time? for finance. Do you want to hear something I don't think I've said today? We're using the same method for all of these. Probably seems weird that, okay, currency, is it the same thing as meters cubed per second and velocity? Yeah, it is. And again, we're down to another situation. Currency, it's 50-50. Okay, so that's nice to know. I know as soon as something says a currency conversion rate of 1 this equals that, I'm either going to be timesing by 0.98 or dividing by 0.98. Okay, so anyway, let's just look at how does this help. Firstly, let's use exactly the same method. Start with what we're converting. It says convert $80 Australian. I'll write that down. 80, I get in the habit of writing AUD. Okay, Australian, that's our shortcut for Australian dollars. 80 AUD. We're back to, that's not a fraction. We're back to what we had before. If it's not a fraction, make it look like one. Okay, that's what I want to convert. Well, I'm given this conversion factor. The 1 Australian dollar is 0.98. God, I need to update these slides. That's not accurate anymore. But I don't want AUD, so my AUD is going to go on the bottom. I do want US dollars, and the conversion factor tells me exactly what to write. It says 1 AUD equals 0.98 US dollars. So I was either going to put the 0.98 on the top and the bottom, but there's no debate here. It told me what to do. The AUD had to go on the bottom. So great, my units now are USD. All I've got to do is do 80 times 0.98, which doesn't impress me much. That's Shania Twain, too old. But if I'm thinking back to, oh God, week 5, oh no, 80 times 0.98, I know that my question has only 2 decimal places in it, so I could ignore them, do it, and then put them back. So if I then said, well, now I'm going to do 80 times 98, because I'm ignoring the 2 decimal places, well, I'm just going to do 8 times 98, then stick the 0 on. Here's 98 times 8. 8 8s are 64. 9 8s are 72, plus 6 is 78. So 80 times 98 will be 7840. So what I did, I just ignored the 0, but I stuck it back. And then my answer is meant to have 2 decimal places. So the answer to this one is 78.40. Does that make sense? They're almost the same amount of money. 1 Australian dollar was 98 US cents. Yeah, $78.40 sounds right. Oh, I'll stick with what I said. My units from ANY are US dollars. Great. So you see, 50-50. I'll either times by it or divide by it, and that will tell me what to do. More. Convert 150 euro. Okay. I start with 150 euro. I don't, EUR, I think. Well, it doesn't matter what you write. Write E if you want. You know, as long as you're writing something which is consistent. Oh yeah, EUR right there, David. Look at your own slide. So I'm converting that. I'll make it look like a fraction. I don't want euro. I want Australian dollars. So the EUR is on the top. I'll get rid of it by putting on the bottom. I'm converting to AUD, and it tells me that 1 AUD is equal to 0.75. All right, I can see I don't times by 0.75. I've got to divide by 0.75. To be honest, I would have rather times it. It's easier, but that's the way it went. So there's my answer. Odd looking answer. I'm going to want to tidy it up, but I've got a 150 times 1 on the top, a 0.75 on the bottom, and an AUD. So clearly that's not our final answer. Let's get it to a number. Oh, lots of methods. How much have we learned this semester? How much fun's it been? If you're a fraction person, you might be looking at that and saying, oh, that's 150 divided by 3/4, which is 150 times 4/3. Yeah, that'll do. And then you might say, oh, there's 1 3 there and there's 53s there, so the answer is 200 AUD. Sure, if you're a fraction fiend, great. If you're a decimal person, you might have said, I remember decimals. What we did was we made the denominator a whole number. So I need 2 moves here. In other words, I'm going to times by 100. As long as I do the same to the top, it's all good. So it becomes 150, 100 over 75. That's my answer. And then Well, I'll just do the division. Looks heavier than it is. 75s into 1, nope. 75s into 15, nope. 75s into 150, 2 of them. 2 75s make 150. 75s into 0, nope. 75s into 0, nope. Yeah, all good methods. All good methods. Well, there's only 2. Get carried away. Right, get another one then. Again, I wish that was still true, but it's not. What is 500 Australian dollars in Thai baht? So I'm trying to convert from 500 AUD. I want to get rid of the AUD, so if it's on the top, I'll put it on the bottom, and I want to introduce Thai baht. Apparently, 1 AUD is 32 Thai baht. No worries, Jack. So yeah, all right. It's told me it's not a divide. Yes, it's a times. So my answer is 500 times 32 Thai baht. 500 times 32. Let's ignore the 100 for the moment, the 2 zeros. So we're doing 500 times 32, but I'm initially ignoring the 2. Oh, well crossed out, David. Oh, 32 times 5. 5 2s are 10. 3 5s are 15. So 532s are 160. Hence 532s is 160. Put the 2 zeros back. And there it is, 16,000 Thai baht. 500 times 32 is 16,000. Lucky last one. It'll have to be division. Must be something nasty. Yeah, okay. What's 1,000 Thai baht worth? In other words, convert 1,000 Thai baht to AUD. All right, I don't want Thai baht. So Thai baht on the top, so that would be Thai baht on the bottom. I want it converted to Australian dollars. And it tells me that 1 AUD is equal to 32 Thai baht. Clearly, it's the exact opposite of what we just did. It's a division question. So my answer is 1,000 divided by 32 AUD. So really, the work here isn't this week's content. The work here is, how do I do 1,000 divided by 32? We can do that. Whether you use short division, long division, doesn't matter. Clearly, it's the last example, so it's going to be nastier. I think you'll find that in the final exam, I've done things prettier, like just use a 20 or a 30, made it nicer. Okay, so just know that the final exam isn't set up to be, ooh, let's go hard on this one. It's actually quite the opposite. It's like, well, we've made it to the end, a bit nicer. So, but we've got 1,000 divided by 32. All right, let's get into it then. 32s into a 1 doesn't happen. 32s into a 10 doesn't happen. 32s into 100, I reckon 3 32s will be 96. That leaves 4. I better put some decimal stuff here. Stop doing that. Okay, 32's out of a 40. That's doable. There's 1 32 in 40, remainder 8. 32's in an 80. I'm getting to know a 32 table. I'll check a few random ones. It can't be as much as 3. 2 32s will be 64. And 80 minus 64 will give me 16. My last question to myself is, how many 32s are in 160? And I can check a few things, but I'm going to put a punt on 5. 2 5s are 10. There it is. My answer is 31.25 Australian dollars. There we go. 4 people survived the lecture, and me, 5. Thanks for watching. Thanks to those watching as well on the recording. I hope you survive it. I hope the semester's been okay. Remember, there's drop-ins every day. There's the special in-person drop-in, 1 o'clock Wednesday. Yeah. Thank you for doing the course. Thank you for coming and doing stuff with me. I'd like to think next semester will be in person again, but who knows? It's all right. Till then, come and say hello in drop-ins and stuff. Is anyone still alive? Have I killed you? Christiana. All right, I'll stop recording. Cheers, Caitlin. Cheers. Recording. You can stop.